where exactly is ground zero of climate change? Some experts say it's the Arctic, although others say it's the tropics. Or maybe Alaska. But possibly Chad. Unless it's Greenland. Although other experts insist it's Florida. Or maybe Australia. Or the Philippines. Or Texas. Or Bangladesh. Except it could also be the entire landmass covering Eastern Europe, Scandinavia, the former Soviet Union, and northern China.
Anyway, you get the idea. Climate scientists make enough guesses to cover the whole world, and then no matter what happens or where it happens, they can point to it afterwards and say, aha, just like we predicted. And journalists everywhere can say their own nation is hardest hit. But the real ground zero of global warming isn't on the ground at all. It's up in the air, about 10 kilometers high over the equator in a region of the atmosphere called the Tropical Troposphere. For 40 years now, climate modelers have been saying that if you want to see the earliest and clearest sign of greenhouse gas-induced warming, you should look there. So, it's what we're about to do. For the Climate Discussion Nexus, I'm John Robson, and this is a CDN crystal ball check on the Tropical Troposphere hotspot.
The lowest layer of the Earth's atmosphere, up to about 1 kilometer, is called the boundary layer. The next layer up is called the troposphere, and above that is the stratosphere. The top of the troposphere is about 10 kilometers above the polar regions, but in the tropics it rises to about 16 kilometers. The troposphere layer is where the big air movements take place that create our weather patterns. This includes convection, wind patterns, cloud formation, storms, and turbulence of all kinds. Jet aircraft aim to fly at the top of this layer where the air is more stable. The troposphere over the tropics plays a key role in the climate system. Most of the solar energy that drives our climate enters here. And because water vapor is a powerful greenhouse gas and tropical air is so moist, there are powerful positive feedbacks here that drive global warming.
At least, that's the theory. And it's been the theory for a long time. In this 1985 report of the US Department of Energy, we get to see some of the earliest predictions by NASA climate scientist James Hansen and his colleagues. And they said, look to the tropical troposphere if you want to see the warming. So, we're about to. Just as soon as I explain about this tropical tropo thingy terminology that's potentially confusing because of the two tropos words, one being the tropics, which is the bit of the Earth between the northern and southern parts, and the second being the troposphere, which is the bit of the atmosphere between the stuff that's really low down and the stuff that's way up high. So yes, there's a non-tropical troposphere and a tropical troposphere, and we are looking at the latter.
Specifically, the chart on the left showing warming in the winter, and the one on the right shows warming in the summer. We'll focus on the one on the left for now. The bottom left to right axis is geographic, extending from the North Pole at the left to the South Pole at the right. So the tropics are the band in the middle, from 20 degrees north to 20 degrees south. Meanwhile, the down to up axis is also geographic, but going from down at the Earth's surface to way up in the sky. And it's marked in kilometers on the left and pressure in millibars on the right, which obviously vary together. And the troposphere goes from just above the surface to about 16 kilometers up.
Okay though, where's temperature if it's north to south on the x-axis and earth to sky on the y? And here's the clever bit. The various lines on that chart are like the contour lines on one of those topographical maps that you so enjoyed in high school geography. Except, instead of those lines indicating height, they represent temperature change. And of course, you could do such a chart with those lines measuring temperature. But what interests us here is how much the atmosphere in the middle of the chart, that is, in the tropics going left to right, and in the troposphere going bottom to top, how much the temperature of the atmosphere there has changed since 1979, and how much the models and the modelers thought it was going to change if CO2 doubled.
So now, coloring in where the increase is greatest, that red circle on the left stands for 7 degrees Celsius warming in the winter, and the one on the right between 6 and 7 degrees Celsius warming in the summer, which will average to 6.5 degrees. So that's what the computers said 38 years ago would happen if CO2 doubled. In fact, it has risen since then by over 20%. So we're a fifth of the way to CO2 doubling, which means we should have seen about a fifth of their prediction come true by now. Or a bit more, because global warming theory says temperature responds more at lower levels of CO2 than at higher ones. So a fifth of 6.5 degrees is 1.3 degrees. That's how much warming the models predicted if CO2 went up as much as it did over the last 38 years. And spread out over 3.8 decades, it's 0.34 degrees per decade. But since the models also predict a bit of a delay before the system fully responds to increased GHGs, we're rounding it down to about 0.3 degrees per decade. That's the rate of warming we should have seen over the past 40 years in the tropical troposphere, if the models are roughly right.
While not all climate models predict warming that fast, they do all predict that the warming will be fastest in the same part of the atmosphere, that tropical troposphere. And the models also indicated that we should have seen the pattern by now. In a 2006 report from the US Climate Change Science Program, they said this is the pattern we should have seen over the period from 1958 to 1999. And in the 2007 IPCC report, the author said this is the pattern we should have seen over the whole 20th century. And now, a word from our sponsor, and that's you. Because at the Climate Discussion Nexus, we're dependent upon support from our viewers and our readers. Please go to our donate page, make a one-time pledge, or if you can, a monthly one. I'm not talking a lot of money though. If you've got it, we'll take it. $2 a month, $3, $5. That's the sustaining funding that we need to produce these videos on our newsletter. And now, back to me. That 2007 report also said it's the pattern we will see in the future as CO2 levels keep going up. And we won't have to wait long because it emerges quickly in response to greenhouse gas emissions. In Chapter 10 of the 2007 IPCC report, specifically on pages 764 to 65, it says,
Upper tropospheric warming reaches a maximum in the tropics and is seen even in the early century time period. The pattern is very similar over the three periods, consistent with the rapid adjustment of the atmosphere to the forcing. These changes are simulated with good consistency among the models.
Got the picture? And yes, graphics got better between the 1980s and the 2000s. So, that big hot red boil in the middle of the diagram is ground zero, or air zero if you like, for climate change. It, not Ottawa or Auckland, is where the effects of global warming should be most evident. And luckily, we have some actual evidence here, as well as some computer model predictions.
Temperatures in the troposphere have been measured independently by weather satellites since 1979, and weather balloons since 1958. So there's data we can check, which they did in that 2006 US Climate Change Science Program report, and found a problem. Here's the pattern as colorfully predicted by 4 different climate models. Remember, yellow, orange, and red mean warming, and blue and purple mean cooling. So, a hot time in the old troposphere this decade. Except, here's what the weather balloon data showed.
Not the same, is it? Instead of a lot of warming in the tropical troposphere, it's a mix of a little warming and a little cooling. And as the report authors had to admit, it's kind of awkward.
A potentially serious inconsistency, however, has been identified in the tropics. Figure 4G shows that the lower troposphere warms more rapidly than the surface in almost all model simulations, while in the majority of observed datasets, the surface has warmed more rapidly than the lower troposphere. In fact, the nature of this discrepancy is not fully captured in Figure 4G, as the models that show best agreement with the observations are those that have the lowest, and probably unrealistic, amounts of warming.
How is it that the models that best fit the actual data are said to have, quote, probably unrealistic, end quote, amounts of warming? This is a very new kind of science. despite which the mismatch caught people's attention. Of course, it's no big deal if some model gets some detail here or there wrong. This is not an exact science, to put it mildly. But in this case, it is a big deal because the prediction that didn't fit observed data is one that all the models make. They all say if you want to see the warming effect of greenhouse gases, it'll be fastest and strongest in the tropical troposphere and should be very evident by now, so look there.
This finding led to the Great Tropical Troposphere controversy. Some authors said the data are probably right, but the lack of warming isn't a big deal. It's bound to come soon. Others said maybe the data are wrong, and we'll soon discover that the warming has been there all the time. And over the years since 2006, the tropical troposphere has warmed a little more, but still not nearly as much as predicted. Instead, over time, the gap between models and observations has just kept growing. As climate models proliferated and were refined, they all continued predicting rapid warming in the tropical troposphere, at rates ranging from 0.16 to about 0.44 degrees per decade. Perhaps because their creators were certain it would happen and built it in. But nature has not cooperated. Weather balloons and satellites have only recorded between about 0.06 and 0.12 degrees per decade. By 2018, the gap had widened to the point that the temperature observations from the middle of the tropical hotspot had fallen below the low end of the model projections. Here's a more familiar sort of graph, showing time on the x-axis along the bottom and temperature in the middle of the predicted tropical hotspot going up the y-axis.
There's been one attempt to move the goalposts by focusing away from the failure to get the warming trend right and focusing instead on what's called the, quote, amplification ratio, end quote. What the modelers say here is all they can really predict is that the troposphere will warm faster than the surface. If the models predict too much warming at the surface, it gets amplified into way too much warming up above. And if they dial down the surface warming in the models to something closer to the real world, the troposphere wouldn't look so bad either. Okay, but it still means the models have a warming bias. It just moves it down to the surface from 10 kilometers up.
And even still, the models get the amplification rate wrong. When a pair of expert statisticians looked at how to measure real-world amplification ratios, they discovered most datasets report they are less than 1, indicating less warming in the lower troposphere than at the surface. In other words, the models significantly overstate the amplification rate too.
So here we are in 2021, 15 years after the, quote, potentially serious inconsistency, end quote, was noted in that government report. The models predict too much warming and too much amplification. Yes, there's been some observed warming, but there's been nothing like what was predicted, and the inconsistency isn't going away. On the contrary, in the latest generation of climate models, it's worse than before.
The literature drawing attention to an upward bias in climate model warming responses in the tropical troposphere extends back at least 15 years now. Rather than being resolved, the problem has become worse, since now every member of the CMIP-6 generation of climate models exhibits an upward bias in the entire global troposphere, as well as in the tropics.
So apparently, the people who make the models took seriously the idea that those models that actually matched the data were unrealistic, while those that did not were spot on. As Chico Marx once said, "Who are you going to believe, me or your own eyes?" End quote.
We now have multiple data sets, and they all tend to say the tropical troposphere isn't warming the way the models predicted. So could all the data be wrong? Let's ask an expert. John Christy is an award-winning professor of atmospheric science at the University of Alabama in Huntsville. He spent his career developing and analyzing global temperature monitoring systems. He and his colleague Roy Spencer pioneered the technique for using satellites to measure atmospheric warming, an achievement which earned them NASA's Medal for Exceptional Scientific Achievement.
Well, that has been around for at least 20 years, that our models are right, it's the real world that's wrong. And so various ways to try to explain the way the observations have occurred, but over time we've had more than one satellite data set independently produced, more than one balloon data set independently produced. We have reanalysis where the big weather centers create these maps of temperature and so on. And they all show the same thing, that that part of the atmosphere is not warming. So with so many independent empirical pieces of evidence, it's hard to make that case anymore that the observations might be wrong. Over the last 50 years or 40 years, whatever, you would think there would be an increase in the agreement between observations and the models. And in some cases, some variables, that's true. But here in this very fundamental variable, the bulk temperature of the atmosphere, I mean, this is what greenhouse warming is how much extra heat is accumulated in the atmosphere. That without getting that right, it indicates to you that the physics is, or I should say the model components are straying even further from the physics, not getting closer to them. And so we see the result, which indicates to you, this is a basic problem with models, is they're not based on fundamental physics. They're based upon approximations of what happens in the atmosphere. And so when they tune these approximations to fit the surface record, those approximations don't work in the upper atmosphere, which means they're not correct. And they need to go back to the drawing board in that part. From what we found, the amount of heat that is being retained by the models is much greater than what we actually see in the real world. So this is important in the sense that it's a test metric. In other words, all the models show this should be happening when you increase greenhouse gases, when you increase that heating amount. And it's something we don't find, which means the real atmosphere evidently has ways to expel that heat that the models don't allow. It turns out that the models that agree most with the actual observations, you know, they're still too warm, but they're closer to it, are the ones that are least sensitive to carbon dioxide, the ones that have the lowest warming rate at the surface. Scientifically, it's just amazing or almost incomprehensible, because in the scientific method, we make a claim and then we test that claim against independent data. And if a claim fails in that test, we go back to the drawing board and restate the claim or modify our result or just say our result is wrong. We don't see that here. We see model after model continuing to come forward with these scary scenarios of temperature rates that are just still not happening in the real world. I mean, remember, what we were comparing in our papers, recent publications, is the temperature change that should have already happened if the models are correct on carbon dioxide. So this is a real, simple, and direct scientific test of these claims. Remember, a climate model is only a hypothesis. It's only a claim. And to show that there's a real problem with this claim, it meets with some vociferous responses because there is so much built upon the notion of climate alarm or climate crisis or climate emergency that when you show up very simple and direct evidence that these claims can be falsified, you are touching a huge, well-funded organization that will not like to see that message out.
So this mismatch is a very serious problem. And in discussing it, the 2006 report did look at what might be causing it. Quote, it may arise from errors that are common to all models, from errors in the observational data sets, or from a combination of these factors. The second explanation is favored, but the issue is still open, end quote. The second explanation is favored. Got that? Given a choice between the models and theory being wrong or the data being wrong, quote, the second explanation is favored, end quote. Why? Not because the evidence supports it, that's the whole problem. Just possibly because we're determined to believe the theory no matter what that silly old data says. So yes, the tropical troposphere is ground zero for climate change, including the fundamental scientific and ethical issue of what to do when the predictions don't fit the data. For the Climate Discussion Nexus, I'm John Robson, and that's our crystal ball check on the tropical troposphere hotspot.